Okay, so now we have question number 5 from S1 June 2013, a replacement paper from the legacy papers, not from the IAL, from the GCE papers. Okay, now in this question, a researcher believes that parents with a short family name tended to give their children a long first name. A random sample of 10 children was selected, and the number of letters in their family name, X, and the number of letters in their first name, Y, were recorded. Okay, the data are summarized as follows. So this gives us an indication of, right, that's the sum of all the letters in the first name from those 10 children. And the sum of all the second names, the sum of all the letters in the second name from those 10 children. And these are the squares, the sum of the squares of the numbers in the first name, and so on and so forth. So these are some of the items that we're going to use in our answer. Okay, we've got to find SYY and SXY. This basically tells us something about how Y varies with itself and how X varies with Y. Okay, and even if you don't really understand what these things actually really mean, I mean, in S1, you can actually just get by just looking at the formula sheet, and you'll see exactly what to do. Okay, it's pretty simple stuff. It looks a bit complicated when you first look at it, but it's actually very simple. So we need SXY. What did we need? Sorry, we needed SYY and SXY. Okay, so SYY. Let's go here, even the right letters for us. So we'll let's take this, I'll just copy and paste it across. Okay, I'll take these and put them in the previous page. Okay, these are the formulas that we'll need for this question. Okay, let's just make it a bit smaller here. Okay, so now for SYY, what we're going to use this form. We're going to use a form over here. That's always an easier form to use according to what we've been given. So we use these forms of the equation. Okay, so now, so SYY. Let's start with that. SYY, as we're told here, is equal to the sum of y squared minus the sum of y and that squared, okay, over n. So we can see from here that n is equal to 10 because there are 10 samples that were taken. Okay, so we're going to have the sum of y squared, which is already given to us here, which is 393, minus the sum of y all squared, which is going to be 61 squared, and divided by n, which is 10. And that will give us an answer for SYY. Simple as that. Just following the formula exactly as it's been given to us. So we have 393 minus, and you've got 61 squared, and divided by 10. That gives you 20.9. Okay, that's 20.9. That's how y varies with itself. And now we're going to find how x varies with y. Now that's equal to, as you can see, the sum of xy, which is given to us here. Okay, I'll just write it down. The sum of xy minus the sum of x times the sum of y over n. So the sum of xy is given here as 382. Minus the sum of x, which is 60, times the sum of y, which is 61, over 10. And that will tell us how x varies with y. Okay, so you got, let's just change these. That's 382. Okay. All right. 380. Okay. 382 minus 60 times 61. Sorry about that. One of my students got his calculator for his exam. Okay, let's see. Let's go back here. Sorry, 382 minus 60 times 61. 60 times 61 over 10. Okay, and that will give us 16. Okay, so that's part A. Simple as that. You don't even really have to understand what you're doing here. You just have to just go to the formula book, take what you need, and just put everything in the right place. Okay? All right, that's part A done, and I'm going to do part B in a minute. Okay, let's move straight on now to part B. It says calculate the product moment correlation coefficient R between X and Y. Okay, now that, again, straight away we can go to the formula book. Okay, the formula book, which is on the next page. We can look down here and we can see R is equal to, and they gave us what we need. So let's just copy that and paste it in our page. So we need this basically. Okay, so what does this mean? R basically tells us how closely correlated, these items are, the first names and the second name, how closely correlated they're, what the correlation is, and how closely, whether they're strongly or weakly correlated. Okay, so we need to have, we need to have SXY, which we found, SXX, which was given to us. Okay, and we need to find, okay, so SXY we found already as 16, divided by the square root of SXX, which was given to us in the question. If we go, scroll up a bit, that's 28. So you got 28 times SYY, which is how Y varies with itself, which we found as 20.9. Okay, when I calculate that, it will give me my answer. So we have 16 divided by the square root of 28 multiplied by 20.9. Okay, and that will give me 0.6614. 0.6614. Okay, so there we have the product moment correlation coefficient. Okay, so we found the value of R. Now, that's part B. Okay, now part C says state, giving a reason, whether or not these data support the researcher's belief. Well, the researchers believed that a short first name will lead to a long second name. A short family name, sorry, would lead to a long first name. Okay, so when one of them was longer, the other one would be shorter. Okay, so if the family name was short, the first name would be long. So that gives you an idea of negative correlation between the first and the second name. So the researcher's belief would lead to negative correlation. Okay, so you can say according to the researcher, according to the researcher, there should be negative correlation. Okay, correlation. Okay, our value of R suggests positive correlation. Although it's very weak, but it's okay, correlation. I spelled that right. Okay, so therefore, data do not support his view. Okay, so that's part C. I'll go on to part D in a few minutes, in the next video in fact.